Algebra 2, Chapter 4, Section 3, Matrix Multiplication. In this lesson, we're going to learn how to multiply by a matrix and a scalar, and to multiply two matrices. So, to multiply a matrix by a scalar, okay, you just multiply it by a real number. The example here is 3 on the outside of the matrix 3, 5, 2, 8. You're just going to multiply, basically distribute that 3 to every element within the matrix. The real number factor, such as 3, this is called the scalar. Okay? So here's our example. Find -3 times this 2 by 4 matrix. Okay, we're just going to distribute that -3 to every element. So -3 times 15 is -45. -3 times -12 is 36. -3 times 10 is -30. And -3 times 0 is 0. Now, -3 times 20, -60. -3 times -10 is 30. -3 times 7 is -21. And -3 times 0 is 0. Pretty self-explanatory what's going on. So let's look at the next example. Find the difference between 5a minus 3b. For matrix A, a 2 by 3 matrix, and matrix B, also a 2 by 3 matrix. So we're just going to multiply matrix A by the scalar 5. So let's set that up. 2, 1, 3, 4. -7, 5. And we're going to subtract 3b. That's 3, 0, 6 up top, -1, 8, 2. So, set the first one up. Again, we're just going to distribute the 5 to every element. So 5 times 2 is 10. 5 times 3 is 15. 5 times -7 is -35. 5 times 1 is 5. 5 times 4 is 20, and 5 times 5 is 25. So now we're going to minus the right side. So 3 times 3 is 9, 3 times 0 is 0, 3 times 6 is 18, 3 times -1 is -3, 3 times 8 is 24, and 3 times 2 is 6. So we're going to subtract these. Okay. So 10 minus 9 is 1. 15 minus 0 is 15. -35 minus 18 would be -53. 5 minus -3 would be 8. 20 minus 24 would be -4. 25 minus 6 would be 19. So we have 115, -53, 8, -4, 19. Okay. Use matrix A and B to find 5b minus 4a. So 5b minus 4a. So let's zoom in, make it a little easier for us to read. 5b minus 4a. So there's a 5 in front of this b, and there's a 4 in front of the a. So 5b, 306, -1, 82, minus 4 times 2, 3, -7, 1, 4, 5. So distribute the 5. 5 times 3 is 15. You get 0 and 30 up top, -5, 40, 10 at the bottom. All this subtract 4 times 2 is 8. 4 times 3 is 12. 4 times -7 is 28. 4 times 1 is 4. 4 times 4 is 16. 4 times 20 is 20. 4 times 5 is 20. So now we're just going to subtract these. 15 minus 8 is 7. 0 minus 12 is -12. 30 minus -28 is 58. -5 minus 4 is -9. 40 minus 16 is 24. 10 minus 20 is negative 10. And there we go. Okay, I think we got a good understanding of this. We'll go ahead and let you work this one on your own. Just a plus 6b. Pretty easy stuff. You should be able to do that on your own. Pause it for a second and work it out. So now that you're back, you can double check your work. You should have gotten 23, 29, negative 5, 52, and 17. Okay, moving on. Scalar multiplication. If A, B, and O are n by n matrices and C and D are scalars, then CA is an n by n matrix. CD times A and C times DA is the same thing by associative property. C times the multiplication of matrix, or the sum of the matrix A plus B, is the same thing as C times matrix A plus C times matrix B. And scalar C plus D times A is the same thing as C times A plus D times A. 1 times A is A, and 0 times A is 0. Okay? So now we're going to solve a matrix equation with scalars. So I have 4x plus 2 times a 2 by 2 matrix equals a 2 by 2 matrix. So let's rewrite this. So 4, that's a capital X, that's a matrix, plus 2 times 3, negative 2, 4, 1 equals 10, 0, 4, 2. First thing we're going to do is we're going to distribute the scalar. So I'm going to get 4x plus 6, 8, negative 4, 2 equals 10, 4, 0, 2. Okay, so we're going to subtract this matrix to each side. So when we do that, I'm going to get 4x equals 10 minus 6 is 4. 0 minus 8 is negative 8. 4 minus negative 4 is 8. And 2 minus 2 is 0. So now I'm going to multiply everything by 1/4. So x equals 1/4. 4, negative 8, 8, 0. So I'm going to multiply everything by 1/4. So I'm going to get x equals 1, negative 2, 2, 0. So I got 1, negative 2, 2, 0. Double check. I sure did. So we're good. So moving on. Solve 2x equals the sum of these two. So let's just 2x equals, let's go ahead and add those. 4 plus negative 2 is 2. 12 plus 0 is 12. 1 plus 3 is 4. Negative 4 plus 4 is 0. So x is going to equal 1/2 2, 4, 12, 0, which is going to equal 1, 6, 2, 0. So matrix X in this example is 1, 6, 2, 0. Okay, I think you get the understanding of how to do this, so we'll skip this one. All right, to perform matrix multiplications, multiply the elements of each row in the first matrix by the elements of each column in the second matrix, and keep adding the products. So let's just zoom in on the example. So we need to find the products of these 2 by 2 matrices. So the first thing we're going to do is we're going to multiply the first row by the first column. We're going to match elements. So we're going to match the first element of each. So we're going to have a matrix that looks like this. Negative 1 times negative 3. First element. And then we're going to add the next elements, 0 times 5. And that's going to be the first row, first column of the new matrix. Okay, you can follow along right here. That's what they've done. First row, first column. They're going to come up with the 3 once you solve it. The result is the element in the first row and the first column. Repeat with the rest of the rows and the rest of the columns. So you go first row, second column. You're going to get negative 3. First row, second column. Multiply matching elements. Add them. No more columns. Go second row, first column. And then sum them up. And then second row, last column. And then sum them up. Okay, we're going to do some examples to make sure it makes sense, and then we'll go from there. All right, so it says find the products of negative 3, 3, 5, 0, and negative 1, 3, 4. Okay, so here we go. We're going to draw our new matrix. We're going to make it a little big just to kind of over-exaggerate. So we're going to go first row times first column. So we're going to match elements. So it's going to be negative 3 times negative 1 plus 3 times 3. Okay, so that's first row, first column. So let's go first row, second column. So that's going to be negative 3 times 0 and 3 times negative 4. Okay, there's no more columns left in the last matrix, so now we'll go second row, first column. We'll multiply matching elements, so that's going to be 5 times negative 1 plus 0 times 3. Now we go second row, second column. 5 times 0 plus 0 times negative 4. Okay, there's no more columns in the second matrix, so we are done. Now we just got to simplify. So let's just simplify. Negative 3 times negative 1 is 3. 3 times 3 is 9, so it'd be 3 plus 9, so that would be 12. Over here, negative 3 times 0 is 0. 3 times negative 4 is negative 12, so it'd just be negative 12. 5 times negative 1 is negative 5 plus 0, so it'd just be negative 5. And then 5 times 0 is 0, plus 0 times 4 is 0, so the answer would be 12, negative 12, negative 5, 0. So that's my new matrix. It's a 2 by 2 matrix. Okay, moving on to the next example. Okay. To find the elements Cij of a product a matrix AB, multiply each element by the ith row of A by the corresponding element of the j row column, and then add. Okay. A used record store sells tapes, LP records, and compact discs. The matrix shows today's information. Find the store's gross income for the day. Well, they sold tapes, LPs, and CDs at $8 each, $6 each, and $13 each, and they sold a total of $9, $30, and $20. So we're going to set up a matrix. We set up a 1 by 3 matrix, and we're going to multiply it by a 3 by 1 matrix. And we just match corresponding elements. So we get $512. Okay, next example, 5A. Find the product of these two matrices. Well, the first matrix is a 1 by 2 matrix, and the second matrix is a 2 by 1 matrix. So we're going to be able to multiply them, and we're going to get a 1 by 1 matrix. So match first row, first column. So we're going to get 12 times 10 plus 3 times negative 5 which should be 120 minus 15, which should be 105. Okay, next example. Find the product of these two. The first matrix is 2 by 1 matrix. The second matrix is a 2 by 2 matrix. Well, since the rows and columns don't match up, remember we talked about rows times columns and rows times columns. If the rows and columns or the columns and rows don't match up between the first and the second one, the product is undefined. Okay, next example. And this is just talking to us about what we just talked about with the dimensions. The product of two matrices A and B exists only if the number of columns in the first one is equal to the number of rows in the second one. All right, so the property is this. If matrix A is an n by n matrix and matrix P is an n by P matrix, then the product of the matrix AB is an m by P matrix. So for example, matrix A here is a 3 by 2 matrix. Matrix B is a 2 by 4 matrix. So the first one was 3 by 2. And the second one was 2 by 4. So we're going to make a new matrix with 3 by 4 dimensions. Okay? So determine whether a product matrix exists. So matrix G and matrix H. So G is a 3 by 2 and H is a 2 by 2. So can we multiply G by H? Absolutely. Because when we multiply G by H, I'm going to have a 3 by 2 times 2 by 2, which is going to yield me a 3 by 2 matrix. Okay, so GH is defined. Product HG, well, the first matrix H is a 2 by 2, and the second matrix is a 3 by 2. Since these do not line up, since the column of the first one and the row of the second one don't match, that one is not equal. So the product is undefined. Okay. So let's just kind of end on some properties. Matrix multiplication has some properties of real number multiplication. If A, B, and C are all matrices, all right, that are n by n size, then AB is an n by n matrix. AB times C is equal to A times B times C. And then distributive property holds true and the multiplicative property of 0 holds true. Okay. So with all that information, you should be able to now multiply basic matrices together with scalars and matrix multiplication with each other.